Hello and welcome. Thanks for joining me for this webinar tonight. Can everyone hear me? You can let me know in the chat. Okay, we've got one. Yep. Yes, great. Great, we can get started. My name is Tierney Steelberg, and I'm a library science master's student at the University of Michigan. And tonight's webinar is data presentation, showcasing your data with charts and graphs. I'll start by offering some general tips and tricks for presenting your data effectively, and then I'll go through some different types of charts and graphs that are handy to have up your sleeve. These ideas are ones you can impart to your students and patrons, and you can use similar exercises to help them think critically about data presentation. The focus is on simple, attainable ways of presenting your data. Chart types you could create without too much trouble, and chart types you could help others create. Jillian will monitor the chat during the webinar. Please feel free to ask questions or make comments there at any time. She'll let me know, and I'll pause and answer. I'll also be asking questions of my own throughout this webinar to spark our group discussion. You can respond to them in the chat, and I'll read your answers. Please feel free to discuss things with one another in the chat as the session happens. Jillian's pushing out a link to my slides so you can follow along in another window if the slides here in the webinar aren't legible enough or are a little blurry. Okay, let's dive in. To start off, let's look at an example of a run-of-the-mill Excel chart. What do you think of this data visualization? You can let me know in the chat. So it looks like Kristen is worried about it being 3D. It seems like a good worry to have. Why are you worried about it being 3D? What kind of effect does that have on the visualization? She says, sometimes it skews my sense of the contrast between numbers. That's an excellent point. Does anybody else have any thoughts or comments on this particular visualization? So Stu Smith says, not labeled, so we know what we are looking at. That's a good point, too. It's really hard to see what's going on exactly in this particular chart. And Jennifer says she wants to see the green columns. That's also a great point. They're almost invisible with the other columns in front of them. So those are all really great points. This 3D bar chart is a good example of what not to do when trying to convey an argument or make a point with data. Luckily, this example isn't real. It's a sample chart from an article by Naomi Robbins about alternatives to 3D bar charts. But there are plenty of examples of charts like this in articles and reports that we encounter every day. It's a chart type that anyone can make in Excel, and many people are swayed by the ability to use many colors and 3 whole dimensions, not realizing a chart like this obscures rather than highlights their argument. Let's start by going over some general rules of thumb for data presentation applicable to all manner of charts and graphs. The first rule is clarity and simplicity are key. Let the data speak for itself. Keep it simple. Avoid unnecessary ornamentation. And if your visualization starts getting too crowded or busy, consider splitting things up into multiple charts. This will help your readers analyze the point you're trying to make. This multi-panel display of bar charts offers an alternative to the torturous 3D chart that kicked off this webinar. Instead of large bars in front covering up the ones in the back, each set of bars gets its own small chart, and with the unit smarts like this, they can still all be compared to one another. The next rule of thumb is, make it easy to read and interpret. There are a number of things you can do to help your readers out. Do you think this bar chart, which shows results from a poll, is easy to read and interpret? Why or why not? Let us know in the chat. Jennifer says, ouch. Kristen says, Justin calls that small multiples because we see lots of mini-bids on one screen page. Great point. And impressive to have done. So those are great answers, and this is truly an example of what not to do, just like that 3D bar chart. This is from a blog post by Nathan Yao of the blog Slowing Data on 6 easy steps to make your graph really ugly. It's a doozy. Let's work backwards to figure out how to facilitate the reader's comprehension of this graph. A poll on what data-related area his readers were most interested in. Yes, Kristen, that's right. He wrote Data Points, which is an excellent book. It's in the further reading section for this webinar. So the first step in making this easy to read and interpret is organize values in a meaningful order. This allows the reader to more easily make comparisons and inferences. Check out the new version of the chart. Already this makes a world of difference, so the distracting colors are still there. Next step, provide a legend and labels when necessary. Clarify the unit. It's hard to see with this color scheme, which we'll deal with in a second, but unlike the previous bar chart, this one shows that we are dealing with percentages. It now even includes the raw number of votes in parentheses after the percentage value of each element. Finally, use a simple color scheme to avoid unnecessary distractions, and avoid using color combinations that are difficult to distinguish. Keep in mind that some readers may be colorblind, so don't use distinctions between red and green or blue and yellow to convey crucial information. Look at the poll results now. Much easier to read and interpret. Next rule of thumb is respect visual and mathematical principles in your charts and graphs. Size two-dimensional shapes proportionally according to their area rather than their length or diameter. Notice how this example is misleading to the reader. The large bubble that represents 391 is many times larger than the small 257 bubbles. The figure underneath shows what the size of the large bubble should be when sizing by area. And next to it, on the right, it shows that the current bubble size implies the number 1,676, many times larger. As we already discussed, three-dimensional charts are difficult to read and interpret. Keep your charts and graphs into two dimensions to allow your readers to analyze your charts more effectively. What do you think of this chart? Do these icons add to this bar chart of the mean heights of men in different countries? Let me know in the chat. Someone says lots of wasps. Yes, that's about right. They're all wearing the same shirt, too. Smith says a line would accomplish the same point, which is very true. It's telling, I think, that the first thing that Jennifer noticed was that it was lots of wasps, because that means we're seeing the picture rather than the data that's being presented. Kristen says, is head the same size regardless of the size of the data? Hard to tell. I think it looks like the head is being stretched slightly. It's the same width, but the heads at the end seem taller than the ones on the right. So the heads are longer, I guess. So those are all good points. In general, it's best to forego icons in the data visualization itself. Representative icons can definitely be useful in some contexts, but not right on a chart or graph. Here, all they're doing is cluttering up the chart and making it harder to read and focus on the values associated with different countries. This chart also commits the cardinal sin of starting the bars at a value other than 0. This is misleading as well, since the bars of a bar chart are supposed to represent whole values. When creating a chart or graph, think about what your data represents and present it accordingly. One final rule of thumb. Definitely play around with different types of charts and graphs as you explore what kind of visualization is a good fit for the data you're working with. Excel and Google Sheets are good starting points. You can switch from chart to chart at the click of a button, and it's easy to customize general elements of your charts. You might find things you hadn't noticed before, like trends, patterns, outliers, or even typos or errors, and you'll definitely get a good sense of what charts and graphs are a good fit for your data. So there you have it, rules of thumb to keep in mind, both when you're critiquing a data visualization and when you are creating one. 1. Clarity and simplicity are key. 2. Make it easy to read and interpret. 3. Respect visual and mathematical principles. 4. Play around with your data. Do you have any questions so far? Let me know in the chat if you do. Or you can let me know if you have no questions. Great. Jennifer says, so far so good. Susan says, no questions. Nice image citations. Thank you. I learned that from Kristen. All right. Let's move on to chart and graph types. So there's a variety of chart and graph types that are handy to have up your sleeve. So think about the kinds of questions that they can answer and how to make them as compelling and as legible as possible. We'll start with the perennial favorite, the pie chart. Take a look at this pie chart that breaks down the population of the U.S. by state. What conclusions do you draw? And how do you feel reading this pie chart? Let us know in the chat. Jennifer says, I think this is my pie chart for my collection development report for 5620. Did you do a pie chart of U.S. by state? Sue Smith says, only populations for the top 4 states are readable, which is an excellent point. Jennifer says, too much info represented the wrong way. Definitely true. Can't even count how many slices there are in this pie. So those are all great points. This is a very cluttered pie chart. The values are organized meaningfully from largest to smallest going clockwise, starting with California, the big indigo one there, but it's almost impossible to make comparisons. A pie chart answers questions like, what percentage of X is Y? What is the composition of X? Is Y's portion of X bigger than Z's? These two pie charts show the gender breakdown of higher education faculty in 1987 and in 2011. What do you think of them? Does the medium of the pie chart do a good job getting this message across? Why or why not? Smith says, much better use of the pie. Much easier to read when you've got fewer slices of the pie, that's for sure. Jennifer says, yes, simple with limited data presented. Kristen says, agree, we can compare shapes because there's a visual difference. That's very true. So something that these two different pie charts illustrate is that it's hard to compare the segments, these two here, and then the last one that we looked at. It's hard to compare the segments of a pie chart divided into more than 2 or 3 slices. Use a waffle chart, which is up next, or even a bar chart for a whole divided into more than 2 or 3 parts. Like a pie chart, a waffle chart can be used to showcase the parts of a whole or percentages of a total. It consists of a large square divided into smaller squares. Small squares can be shaded in proportionally to the part or percentage that is being represented. The waffle chart can be used to answer the same questions as pie charts. With the waffle chart, the reader can analyze the area of segments or the number of individual boxes that make each segment up. These spatial differences are easier to judge than the angles of pie charts. This waffle chart shows the segments of the U.S. population affected by the healthcare data breaches at Anthem and Premier earlier this year. What do you like about this particular chart? What don't you like? Jennifer said, it took me a while to understand. Interesting. Why was that? Is there a particular reason that you can think of? Sue Smith says, makes me think I have to read right to left. It's kind of a strange way of orienting it. So Jennifer says, but now it makes sense. This is a waffle chart with just 3 different divisions, so it's something that could probably be represented as a pie chart. Kristen says, would like stronger color contrast between 2 blues. That's definitely true. The blues are very close in color. Do you like it more or less than a pie chart? Or are they about the same? Sue Smith says less. Okay, so the pie chart is more delicious. All right, let's move on to the next chart type, bar charts. It wouldn't be a lesson on charts and graphs without an example from Fox News to pick apart. What are your thoughts about this particular bar chart? Does it respect the rules of thumb that we just discussed? Kristen says abstain. All right, Kristen. Jennifer says doesn't start at 0, which is true. And what's the effect of that on how we're perceiving it? Sue Smith says size of bars is off. How do both of those things affect how we're reading the chart? Jennifer says makes us bias, and Sue Smith says overstates the goal. And that's definitely true. The 6 million there looks to be, if you judge it just with your eye, looks like it's maybe a third of the 7,666,000, which is not at all the case if you compare the 2 raw numbers to one another. Those are all very true. The bar chart answers questions like, what element has the highest or lowest X? Or how does X vary across different elements? This is the same bar chart we saw earlier, showing results from Nathan Yow's reader poll on flowing data. It's simple, but it gets the job done. Bar charts are a clean and concise way of presenting poll or survey data, and polls and surveys are a fun way to get your students and patrons thinking about creating their own data and visualizing it. The dot plot is similar to the bar chart in that it showcases values assigned individual categorical elements. But instead of showing the entire value in the form of a bar, it plots the value as a single dot on a graph. The dot plot answers questions like, what element has the highest or lowest X? How does X vary across different elements? Or even how do X and Y vary across different elements? Since a dot on a dot plot doesn't represent a whole value, dot plots don't have to start at 0, unlike bar charts. You can thus use them to zero in on small differences. You can also plot multiple symbols per element on a dot plot. This example simultaneously shows the revenues and profits of a variety of large American corporations. I know it's hard to see, so let's get a little closer to that data. Here are the top 14 elements. What do you think of a dot plot as an alternative to bar charts? Can you think of data you would like to present in a dot plot? Let us know in the chat. Smith says, nice. Does that mean that you like the dot plot, or was that a reply to Jennifer's comment? She says she likes it. And Jennifer says, number of mismatched stocks generated by my dryer per month over a year. That would be a very interesting dot plot, I'm sure. Jennifer says that she has a hard time reading this. Is it because it's so blurry, or is it because of the chart type itself? I know it's hard to see, it's very small. Probably looks better in an article on a sheet of paper. Jennifer says that she thinks it's because of all the white space. And that makes a lot of sense. You'd be able to create this with less white space if you kind of had just these values. The reason this one has so much white space is that I'll go back for a sec. Compared to the last one, those other ones get much closer to each other. They're down towards the bottom. Here's the top one, so their profit and revenue are further apart. Sue Smith says profit and revenue are often represented as stacked bars. It's very true. There's advantages and disadvantages to both chart types, I think. The stacked bar often, I find that I have trouble comparing the stack on the top with one another since the stacks on the bottom are different heights. That throws things off for me. All right, great. We can move on to the next chart type. So maps. Maps are a great way to present data. You can use shaded areas or symbols to convey meaning. A map answers questions like, where does X occur? Where is X most concentrated? Where is X most or least prevalent? Where do the places depicted fall on a spectrum of values? And how does one place compare to another? Here are two different examples of color use in maps. The map on the right shows each Michigan county shaded by total population. The map on the left, on the other hand, uses two different shades to show the percent change in population for each county. Purple indicates a decrease and green indicates growth. And once again, the darker it is, the higher the value, be it negative or positive. What do you think of these two maps? Is it an effective use of color? Are they legible? Kristen said earlier, I missed it about the dot plot, but she saw a chart like that today that colored in the space between the points. The difference between the two data points was easy to notice. That makes a lot of sense. Jennifer says, I would like the purple to be red. That means negative to me. That's a really great point. It's interesting to think about how colors have an association for us, and charts can either use them effectively or not. Sue Smith just says she agrees with Jennifer. So that was a great point. Kristen says green means one thing in one map and another thing in the second map. And that's very true. I think these maps are both from the United States Census Bureau, but I'm not sure whether they were published together necessarily. I just chose to put them together because of their use of color. Definitely some great points and some interesting things to notice about the way we use color in charts and how it can be loaded with meaning that we may not realize, or how there can be expectations for the reading. So on to the next chart type. A line chart or line graph displays data points on a graph plotted according to a numeric variable and a continuous variable, which is often time. The data must be continuous or ordered so as to connect the dots with a line. A line chart answers questions like, how does X evolve over time? When was X highest or lowest? Does X rise or fall in a seeming pattern? This line chart shows the U.S. unemployment rate by month between 2005 and 2015. It tells a story. You can see the unemployment rate climb when the recession hit in 2008. You can display multiple lines on the same graph to show multiple elements and draw comparisons between them. This particular line chart shows the positions for 1,000 people in different areas across the world. This chart was created with Google Public Data Explorer, a fun tool from Google that lets you get your feet wet with large data sets from sources like the IMS or the U.S. Census Bureau. Definitely encourage your students and patrons to check this one out. So Jillian is pushing out a link in the chat to the U.S. Census Bureau data in Google Public Data Explorer. Play around with it for a few minutes. Think about what you notice about the data itself and what you notice about the process of creating a chart. And make note of anything you wish you could do with this tool. We'll team back in as a group and discuss your findings after 5 minutes. Have at it, and I'll let you know when time is up. Okay, that's the timer. That was 5 minutes. So what did you notice about the tool that you were using, about the data you were looking at, and was there anything that you wish you could do with the tool that you weren't able to do? You can feed back into the discussion in the chat. Oh, I see now. Sorry, I scrolled up in the chat and it looks like it wasn't updating. All right, Jennifer says, I like how I can change the graph with my selection input. It's also fun to watch the lines move as the data changes. They're very simple, straightforward, and easy to read. All very great, good points. It was fun to watch the browser change as the new lines appeared and things adjusted. Was there anything that you wished you could do that you felt like you couldn't? Or did you feel like this tool was good for these purposes? Sue Smith says, I like that you could drill down on source data. Very true. That's a great point. And it was nice that Google was transparent about where these were coming from, because I know Google is not always transparent about things like that. Kristen says, I was on my phone and felt that held me back from looking closely. And that makes sense. It's nice that you were able to see things on your phone, though, I know. Not all tools show up well on a phone. So, but it is nice to see it on the browser view to get things a little bit more, a little bigger. Did you like this tool? Would you recommend it to people looking to get their feet wet with large data sets? Sue Smith says yes. Great. Kristen says you could either see big pictures, no labels, or labels and lose the trend. That's true. Yeah. Great. Well, I'm glad you enjoyed it. You guys have some insightful thoughts about using the tool. That's great. Let's move on to the next chart type. The scatter plot or scatter graph displays the values of a data set with two quantitative variables. It plots every individual data point onto a single graph. The position of each point is dictated by the two variables, one on the x-axis and another on the y-axis. It answers questions like, does x correlate to y? What are the outliers in my data? What are the patterns in my data? This scatter plot example shows both faithful eruptions plotted along two variables, eruption duration in minutes on the x-axis and waiting time between eruptions in minutes on the y-axis. What does this data suggest? And how does this chart fit in with our rules of thumb? Let us know in the chat. And I see there's some responses from the Google Data Explorer. Jennifer says, I would have to give my students some parameters, which makes sense. There's a lot to look at there. And it was overwhelming sometimes to be checking things off from a list of countries, a list of states. And Kristen says, yes, we did a lot in 5 minutes. Good model to think about for the grant. Great. Jennifer says, scatter plot doesn't start at 0. That's a good observation. I'm not sure whether a scatter plot needs to start at 0. I don't know whether I feel if it's misleading for it to start at 0 or not start at 0. I wonder if it's maybe like a dot plot or a line chart where you can hone in right on where things are. But that's a good observation because if you're expecting it to start at 0, it can be a bit confusing. Jennifer says, I'm not sure what the line means, the mean average. Kristen says, we need to learn to look for 0. Data isn't always following the rules for math class, which is a good point. And Jennifer, as to your question about the line, I believe it's the regression lines for each cluster of data, which shows, for each cluster, half of the points are above it and half are below. And Sue Smith says, so does this mean the longer the duration, the more time you wait till the next eruption? And yes, I think that's exactly it. there's two clusters of points. The short eruption duration, short wait time, and then the long eruption durations, but then longer wait time. Those are some great observations. And something else to note, I think, is that it's got a clear title, the graph, but it doesn't actually say when this data or where this data comes from, what time of season or what year. And I actually looked for that information, and I couldn't find it. This was a graph from Wikipedia. Yes, exactly, Kristen. There's no source of the data. So it's a handy little scatter plot, and it's illustrative. And there are other examples that make the same point on the internet, that this particular one didn't have its data set, and it was actually flagged for that on the Wikipedia page, but it was still there. So great observations. The next chart type is bubble charts. A bubble chart is similar to a scatter plot. Data points are mapped onto a graph depending on two variables along the x and y axes. But a bubble chart introduces a third variable, the size of the data points represented as bubbles, also conveys information about data elements. A bubble chart answers questions like, does x correlate to y? Does x correlate to z? Does y correlate to z? Are there exceptions to correlations? What are the outliers in my data? What are the patterns in my data? So this bubble chart, which let's look at it a little bit bigger, shows burglaries per 100,000 people on the y-axis and murders per 100,000 people on the x-axis. The bubbles plotted are U.S. states and their size according to their population. This is another data visualization from Flowing Data, the blog. What do you think about this chart? Does it follow the rules of thumb that we discussed earlier? Let us know in the chat. It's hard to see. It definitely looks better. I don't know if you're following the slides on a long gun directly in your browsers, but it's easier to see there. This little tiny state names got very, very blurry. Jennifer says, these are like drops of blood. And Sue Smith says, I just don't get it. So I think what this chart is trying to show is, unlike the scatter plot that we were looking at earlier, it's not necessarily showing patterns, but what's of interest are the individual data points. You can see that each one is a state, and so the bigger the state, the bigger the population. And then the further along it is on the x-axis, the more murders there are per 100,000 people. And the higher up it is on the y-axis, the more burglaries there are per 100,000 people. And so you can see that, Kristen says, ditto Sue, makes me ask more questions. Yeah, it definitely is a complicated one to look at. I think something like this is maybe more of interest to compare one state to another than to look for a general pattern. This is the kind of thing where it would be really interesting to look at outliers, like, Louisiana, what's going on in Louisiana. It's got, it's not very populated, but it's got quite a lot of murders and a sort of medium amount of burglaries. But that is a complicated one. Smith says another reason not to live in North Carolina. Yeah, it is right up there at the top for burglaries and decently far along for murders. So there's also bubble charts that you can find for happier topics. There's a website called Gapminder, which shows bubble charts for things like the average age of mortality or that kind of thing, and you can hit play and it'll show you how it evolves throughout the years and how people in various different countries live longer and longer. We'll move on to our final chart type, which is histograms. A histogram shows the distribution of a quantitative data set. The height of the bars represents the frequency of data points within that particular interval, also known as a bin. You can think of the bins as buckets into which the data points fall. The more data points fall within the range displayed, the bigger the bar. The histogram answers questions like, what are the patterns in my data? In what intervals are data points most concentrated? What is the distribution of my data? Does it skew a certain way? You can change the breakpoints of your histogram, that is to say, change the size of the intervals of the bins or buckets. By changing the way you display your data, you can learn more about its distribution. These two histograms show the same data set, tips received by a waiter at a restaurant. The one on the left has a 10-cent bin width, and the one on the right has a $1 bin width. What do you notice about these two displays of the same data? You can let us know in the chat. Jennifer says 10-cent bin width is hard to understand. That's true. It's very small. But you can see, I think it's interesting, you can see where it jumps up. It looks like it's right in the bin width between, like right before a round dollar number, like 2, 3, 4. So it kind of tells you that people are tipping, probably tipping round dollar amounts, which the other bin doesn't show you. Smith says the 10-cent chart is much more granular. Interesting. Yeah, it's amazing how just changing the breakpoints can really change how you see the data that you're looking at and what conclusions you can draw from that. Those were excellent points. Looks like Kristen might be typing, so I'll wait for her to say what she has to say before I move on. She says the patterns are less obvious on the 10-cent one. And that's true. It's harder. It goes up and down and up and down and up and down. So you're just noticing different things with each one. All right. Those were all the chart and graph types I wanted to show you today. If you'd like to learn more, check out some of this further reading. It's all included in the handout from today's webinar, which Jillian will link to in the chat. Thank you all very much for joining us tonight to talk about data presentations, and thank you for your thoughtful responses and discussions. Before we wrap up, are there any questions you'd like to ask me or your fellow participants? Any thoughts you'd like to share? You can go ahead and do so now in the chat. Kristen says, love the rules of thumb. How'd you like them? That was another Kristenism, the rules of thumb. We have a lot about rules of thumb for information literacy in class. Jennifer says, nice handout. Thank you very much. I'm glad you enjoyed it. It was fun to make. Does anyone have any questions or comments or maybe resources they'd like to share? Data visualizations we've looked at recently? Looks like there's some people typing. So I won't move on. It's just hard to tell. The Blackboard Collaborate interface. The little name box is very small, so it's hard to see what's going on. Jennifer says, at my high school, I'm constantly trying to help science students convert data points to create Excel graphs. It's a battle to help them understand that they need to have a graph that makes sense and not just create a graph. That's a really good point. I think something that I've noticed in the research that I've done is a lot of people just toss in a, toss in a graph for the sake of having a graph instead of thinking about how readers will analyze it, what it will say that text won't, and how sometimes maybe text is better than just having a graph for the sake of having a graph. That's a really great point. So one last thing is I would appreciate your help in evaluating this webinar. So you could let me know what you liked and what you thought could be improved. Actually, we'll send out a link in the chat to a short survey, and if you could fill it out in the last few minutes that we have, I'd be very grateful. Thank you for your help. And I think we can end here. So thank you again for joining me tonight. It was a pleasure teaching this session. Good luck in all your data endeavors. Goodbye.